this is kind of summing up almost everything that we have learned in this chapter so far. And it's been a little disjointed because we did the sine graph, and then we did radians, and then we did the cosine graph, and then we did the whole unit circle. So it's been a little bit all over the place, and I'd probably do it in different order if I really thought about it. But I wanted to go over and be very clear about what's expected on the sine graph and the cosine graph, and then after, towards the end of the period, we'll go over the tangent graph as well. So, with the sine graph, we started at 0, 0. We had not traveled around the circle, so we had a distance of 0, and we also had an altitude of 0. Remember, that was at the point, like 1, 0 on your graph. As you traveled around the circle, the point pi over 2, when you were at 90 degrees, you were at exactly 1 above ground level. As you went down to 180, or 1 pi, you were back at 0 for ground level. As you got as you got 3/4 of the way around the circle at 3 pi over 2, you were at an altitude of -1, and then you came back up to 2 pi. These 5 points are absolutely essential to any sine graph. And the other thing to remember is as you're connecting these, this is not a straight line, this is a curve. Because you have a circular function, you're curving down and back up. So if I continue forward, what would be the next point that I would put on the graph? If I go further this way. Would it be -1? +1. So I'd be up here. And where would I go from there? 3 pi, 0. So that same pattern, and then at 7 pi, I'm going to be back down to -1. That pattern is just going to continue. If I go backwards, I'm going to come down here to pi over 2, negative pi over 2, -1, and come back up to negative pi, 0. Some of the vocabulary that we've talked about, but once again, I want to make sure it's absolutely clear. This single cycle, does anybody remember what that is called? Period. So the distance it takes to complete one cycle is the period. So that means, in terms of one cycle, that means your full distance around the circle. So your starting point, all the way around your circle, back to your starting point. One, not of. So the distance to complete one circle or one cycle. Your standard period is going to be 2 pi. But we are going to work on modifying that in future lessons. Another vocabulary, or piece of vocabulary, was the midline. So I'm going to do that in a dashed line. The midline is just that. It's halfway between your highest and lowest points. So this is important as well when we start moving our graph up and down. And then, does anybody remember the vocabulary word for this distance right here? And it could be up here also. I just happened to put it down here. Anybody remember that vocabulary word? Close. Amplitude. Very, very close. So, there's that. That's our sine graph. And we're not going to label all those things on the cosine graph. The main things that I want you to note are your midline and these 5 specific points. With the sine graph, your start, up, middle, down, middle. So take a moment and make sure you have all that stuff written down. The difference on the cosine graph is what? What's the main difference? Starting point. You start at 0, 1. So your first point is up here. Your next point is at, pi over 2, 0. You go down to -1 for pi, back up at 3 pi over 2, and back up to 1 for your full circle. So that full cycle looks a little bit more, make sure it doesn't look too much like a V, make sure you got a curve there, a little bit more like a teacup. And I'm going to go over that with pencil because that's not terribly bright. And just like the sine graph, it's going to continue beyond that at going positives and going negatives. So what would, if I go out the positive direction, what would my next point be? Yep. And then 5 pi over 2, 0. And then 3 pi, -1. And then 7 pi over 2, 0. So, and I'm only doing this in a dashed line because I want that, and this would continue up again if we continued out. Because I want to make it clear what the one period is. And then if I were to go backwards, what are my points that I'm going to graph over here? Negative pi over 2, 0. And then pi, or negative pi, 1 or negative 1? Negative 1. So, once again, the length of this period is 2 pi, because that's how long it takes to finish one full cycle. My midline is still going to be at y equals 0. It's still going to be just straight across here. That's not terribly important right now. It will be more important later. And my amplitude on this one as well is still 1. So that is the sine and the cosine graph. So the tangent graph, if we're dividing the sine by the cosine to get the tangent, there's a couple of very important spots on this graph. At 90 degrees and 270 degrees, we have an undefined tangent. And that means that we have a vertical asymptote at 90 degrees and at 180. And you can do this with the graph on the bottom of your page if you want to, or you can just wait till you get there. No, 270, not 180, I'm sorry. Got that seemed wrong. So if I look at this, if I have asymptotes at 90 and 270, where else might I have an asymptote? Not 180. This wouldn't be on your graph, just on my graph. Say louder. Negative 90. And then going out that direction, I'm also going to have one at 450, but that's off my graph. So what's happening in between those is I am just looking at what's happening on this table. So 0.58 and 1 and 1.73, and then negative 1.73, negative 1, those are repeating but in an odd pattern. So if I'm graphing these at 0 degrees, I have a tangent of 0. At 180 degrees, I have a tangent of 0. At 360, I have a tangent of 0. Means I'm also going to have a tangent of 0 at negative 180. If I look at my ones, I'm just looking at the ones that are easier to graph right at this very moment. I have 45 degrees, I'm at 1. And at negative 45 degrees, well, I'll come back to that. At 225, I'm at 1. And if you suspect, I would be at 1 if we continue this over. Let's see if you can start to sense that pattern. 405. Just looking at the positive now, and also at negative 135. And then my negative ones happen at 135 and at 315. They're also going to happen at negative 45 and then continuing back. So, what's happening here, what happens at asymptotes in general? It approaches infinitely, but never touches. So what's going to happen here with all of these is I'm coming down from low here and curving up. And then I hit an asymptote, and I'm coming up from the bottom and going up. And obviously you guys don't have this full set here. Whoops, but you should get the idea. So that tangent graph, because of dividing by 0, is going to have asymptotes at 90 degrees, and then with an addition of 100 degrees or a subtraction of 180 degrees in both directions. So now you know what that should overall look like, and I've clarified that. You have the sine graph, the cosine graph, and now the tangent graph. So with the tangent graph, we're not going to work quite as much with this overall. But the points that I want you to pay attention to on the tangent graph are where your asymptotes would have to be, and these 3 points between them, going low, middle, high. But this is not a circular function in the way that the sine and the cosine is. Obviously, it repeats itself over and over and over again, but it's a bit more complicated that way. So, sorry to rush you into that, but I wanted to make sure to wrap that up before the end of the period.